So what we're going to want to do is we're going to want to take either continuous data or, again, discrete data where we have a large number of possible data values and organize that into a frequency distribution like we just looked at on the previous page. So to do that, we have to decide where are we going to start our classes. One thing that you're going to find in statistics is that often there's not hard and fast rules where you always have to do it this way. There are guidelines as to how we can do things, but they're not always hard and fast rules. Now, there are some hard and fast rules, but oftentimes we have guidelines. So what that means is you could do this a little bit differently than what we're saying here, and it would be acceptable. Anyway, how should we choose the lower class limit of the first class? Well, you choose that by looking at your data and find the smallest data value in your data. Now, either your lower class limit of the first class should either be that smallest data value or a convenient number a little bit smaller than it. So that's what we're going to use as our sort of technique. Either use the smallest data value as the lower limit of the first class or a convenient number that's just a little bit smaller than it. Now, what should we use for a class width? Well, to determine our class width, I need to talk about a couple of other things real quick. When we create our classes, we have to do it in a way that every data value will go into a class and it will only go into one class. So there can't be any holes between our classes. Wherever the one class stops, the next class has to start. And there cannot be any overlap. So a data value can only go into one class. So however we do this, again, where our first class stops, the next class is going to start, and so on. And we have to do it so that we have a class for every data value. So to determine a class width, the first thing you have to kind of think about is how many classes do you want in your data? Now, again, this is a guideline. There's no hard and fast rule. Do I want to end up with 10 classes? Do I want to end up with 4 classes? Do I want to end up with 15 classes? How many classes do I want? So usually, again, guideline, usually you're going to want somewhere between 5 and 20 classes. How many depends on your data. First of all, how many data values are there? If you only have 30 data values, you probably don't want 20 classes. If you have a smaller number of data, then you probably want to use a smaller number of classes. If you have a larger number of data, like thousands of data, then you might want to use 20 classes. You might even want more than 20 classes. It just kind of depends. Once you kind of determine how many classes you want, and in this class, you're usually going to be told how many to use, but in real practice, you got to decide that on your own. We can figure out or estimate what the class width should be by taking the largest data value minus the smallest data value and dividing by the number of classes that we want. So find the biggest data value, find the smallest data value, subtract that, and divide by how many classes you want, and that's going to approximately tell you what the class width should be. Now that probably won't divide out to be a nice pretty number, and you probably want to use a relatively simple number for the class width. You wouldn't probably want to use 3.796 as a class width. Instead, you'd probably want to use like 3 or 4 or 5 or 6, a convenient number for the class width. Maybe halves, you might use 2.5 for a class width or something like that, but usually it'll be a whole number. You want it to be convenient. Now, when you do this calculation, we're generally going to round up to a convenient number, and rounding up, just to make it clear, if we round up, that could mean that you end up with fewer classes than you set out for. So you might say you want 10 classes, but when you do this and round up, you might actually only get 9. We generally don't want to round down. If you round down, you could end up with more classes than you set out for. So If I rounded down, I might end up with 11 classes instead of 10, which wouldn't be the end of the world, but usually we round up instead of down. So an example will help make this make more sense, I think. So the data in the table below represent the total fine, including late penalties in dollars, for a simple random sample of 50 parking and camera violations in the city of New York. Construct a frequency and relative frequency distribution of this data. Now this data, I guess I would argue that it is discrete data because we're talking about how much the person pays in a fine for a parking ticket or a camera violation. Now I am assuming from this that this data is coming from back when they were allowed to give you like a ticket from like running a stoplight or something like that with a camera. So that's why they're saying camera violations. It's that kind of thing. And I think that's pretty much no longer in existence anywhere. But anyway, this data came from then. Now, again, I would argue it's discrete data because we're talking dollar amounts and to the nearest penny, so it's countable. But it doesn't matter if you look at all of the different possible values that could occur. We want to look at intervals of values. So I didn't get any instructions other than construct a frequency and a relative frequency distribution. So the first thing that I need to do is kind of think about how many classes do I want. So if I have 50 data values, I might want to use 5 classes or 10 classes or something like that. Probably no more than 10, but also probably no fewer than like 5. Is that a hard and fast rule? Not a hard and fast rule. So I'm just kind of deciding what I want to do. So let's just say, let's use 10 classes. So if I decide that, I'm going to look through my data now, and I'm going to find the largest data value, and I'm going to find the smallest data value so that I can find the class width. So I'm looking for my class width. I'm going to go through this, and I'm going to look for the smallest and the largest data values. So I see 105 here. Is there anything smaller? Oh, right there. So there is our smallest data value, 65.00. Now what's our largest value? 322.61. That's the largest data value. So I'm going to take that largest data value, 322.61, minus my smallest data value, 65.00, and I'm going to divide that by 10. And why am I using 10? Because I decided arbitrarily, let's have 10 classes. If I had said, let's use 8 classes, then I would divide by 8. So if I take 322.61 minus 65 and divide by 10, that is 25.761. Now I'm going to break my rule. Remember, this is guidelines. Guidelines here. So normally we say round up. So I would round up to 26 if I followed this rule specifically or rigidly. But I think it'll be more convenient for me to use a class width of 25. I can add 25 in my head, for example. 26 is a little harder. So this equals 25.761, and I'm going to round that down to 25 and use a class width of 25. Now again, the fact that I'm using a class width of 25 means I'm going to probably get more than 10 classes. So now I need to figure out what my classes are going to be. Well, my smallest data value is 65. So I could either use 65 as my lower limit of my first class, or I could use a more convenient number a little lower than 65. Now 65 honestly would not be a bad number to use. It's nice and round and so on. But I think it would be even easier if I dropped that down to 50 and use the lower class limit of 50, since especially I'm going to use a class width of 25. So I can go 50, 75, 100, and so on. Again, I can do that relatively easy with convenient numbers. Do I have to do that? No. But that's what I'm choosing. So I'm going to go from $50, and that's going to be where I start my first class. Now, the next step is where people goof up a lot. So I want you to pay close attention here. To get the beginning of my second class, I'm going to take my 50, the lower limit of my first class, and I'm going to add the class width. So 50 plus 25 is going to be 75. That's going to be the lower limit of the second class. And that means the first class then is going to stop at $74.99. So any fines between $50 and $74.99 goes into the first class. When it hits $75 fine, that goes into the second class. Now again, if I take 75 plus 25, that gives me 100. So that means this is going to end at $99.99. 100 plus 25 is 125. So this is going to end at $124.99. 125 plus 25 is 150. So this ends at $149.99. 150 plus 25 is 175. So this ends at $174.99. I wrote 170 instead of 175 there. Add 25 again, that's 200. So 199.99. 225. So 224.99, and so on. 250. So 249.99. 275. So 274.99. That's going to go to 300. And so 299.99. And now here, if I were to add 25 again, I would be at 325. So this one's going to end at 324.99. Notice that my largest data value, 322.61, would go inside that. So that's going to be my last class. So once I have my classes established, now I just have the tedious task of going through and counting. How many fines were between 50 and 74.99? How many fines were between 75 and 99.99, and so on. So not hard, but tedious and easy to mess up. I've messed up plenty of times in my life to tell you, you have to be very, very meticulous. So I'm looking for data values in here from 50 to 74.99. So I'm going through my list. I believe that's the only one. So there's only one fine that was from 50 to 74.99. So now I'm going to look for our 75 to 99.99. I'm not seeing any, so I think the frequency there is 0. So now we're going to go from 100 to 124.99. Okay, now we're going to start having some. So we have 105, that's 1. 105, that's 2. We're going to 124.99. Not quite. There's 3. 4. 5. 6. 7. And I think that's it. Now notice there's this $125 one right here, but that $125 one's going to go in the next class, right? Not this one. So I'm going to go through now and look for from 125 to 149.99. So so just before 150, in other words. So I'm going to circle these. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got 10 there. So 150 to 174.99. So here we go. Here's 1. 2. 3, 4, 5, and I think that's it. 175 to 199. There's 1. I'm going to put a slash through it. There's 1, 2, 3, 4. 200 to 224.99. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13. So we are getting down to where we don't have very many left. So now we're 225 to 249.99. So that would be this one. That's 1. That one's not. That one's not. Two, 3, I think just 3. Oh, I missed that one. 4. $250 to $274.99. There's 1 right here. Okay. There's 1 right here. That's 2. 3, 4. 5. I think that's it. 275 to 299. I don't think there's any of those. I think I've gotten them all except the largest value. So I think that's 0. And then there's the largest value here that was in this last class. I'm very hopeful that that at least adds up to be 50. So at least it adds up to 50. Again, that doesn't guarantee that I didn't mess up and count something in the wrong category, but if it doesn't add up to 50, then I know I've goofed up. So again, that's not really hard, it's just very, very tedious. So then I can change these all to relative frequencies. So there's 50 data values altogether. So if I take 1 divided by 50, that is 0.02. 0 divided by 50 would be 0. 7 divided by 50, that's 0.14. 10 divided by 50 is going to be 0.2. So I'm going to write that as 0.20. 5 divided by 50 is going to be 0.1. So I'm going to write that as 0.10. 4 divided by 50 is going to be 0.08. 13 divided by 50 is going to be 0.26. 0.08 again, and 0.10 again, 0 again, and 0.02 again. And again, if I add that all up, that should add up to 1, except possibly because of rounding. Once we have our data organized into a frequency distribution or a relative frequency distribution, we can then graph that data into a histogram for continuous data. Now, so I've given us a couple of grids here. So on the vertical axis here, I have the frequencies, and here I have the relative frequencies. I did not include anything on the horizontal axis yet. I'm going to write those in. So I want to construct a frequency and relative frequency histogram of the parking and camera violation fines data from the previous example. So here's how I do this. I'm going to label on the axis, on the horizontal axis here, the lower limits of each class. So my first lower limit was 50. So I'm going to start here with 50. And then my next lower limit was 75, and then 100, and so on. 125, 150, 175, 200, 225, 250, 275, 300. And then we didn't really have a class that started with 325, but that's what would go on the next tick mark. If there was another class, it would start at 325. And I'm going to do the same thing over here. So I'm just going to duplicate that. Now, for our first class from 50 to 74.99, we had a frequency of 1. So I am going to draw a bar that starts at 50 and extends over to where the 75 starts, and the height of that bar is going to represent 1, or is going to be 1, okay? So this bar in this histogram is representing data values from 50 to just before 75. When we hit 75, that's where the second bar in the histogram starts. Now, the second bar in the histogram really isn't a bar because it had a frequency of 0. We didn't have any data values. So we either don't draw anything, or you could just draw a horizontal line along the axis there. 100 to 124.99, we had a frequency of 7. So I'm going to draw my bar starting at 100 to a height of 7 and extending over to the 125. Next, 125 to 149.99, we have a height of 10, a frequency of 10. So I'm going to extend from 125 over to 150. And then from 150 to 174.99, we had a frequency of 5. And then 175 to 199.99, we had a frequency of 4. So 200 to 224.99, we had a frequency of 13. So that needs to extend up. And then 225 to 249.99, we have a frequency of 4 again. And then a frequency of 5. A frequency of 0. And last but not least, a frequency of 1. So this histogram represents our parking fines and camera violation fines data. So again, I want to make sure I've emphasized this. So the difference between a histogram and a bar graph is that a bar graph, the width of the bar doesn't really represent any quantity. It doesn't mean anything. But in a histogram, the width of the graph represents the class width. That's a difference of 25. And so there's a range of 25 values that go in that first bar. There's a range of 25 values that go in that bar, and so on. Other than that, it's not a whole lot different in the construction. We cannot use lines. When it's continuous data like this or ranges of data like this, I can't do this option because it's not a single value, it's a range of values. So it's got to be rectangles on this kind of graph. If I create the relative frequency distribution, I do the same thing. I'm just using the relative frequencies for the heights of the bars. So the relative frequency of our first class here is 0.02. So now that's 0.05. So 0.02 is not going to quite be halfway. So that would be that. The relative frequency of the second is 0. 0.14. So we won't be quite to the 0.15 mark up here. 0.20. 0.10. 0.08. So we're going to go down a little bit. I probably should be a little lower than that. 0.26, so a little above the 0.25 mark. 0.08, so that's like here again. 0.10, 0, and 0.02. So back to this height. Again, not hard, just a little tedious.